All right, so this is going to be due tomorrow. Um, and number 5 and number 8 are a little different here. Number 5 says how many liters of oxygen are needed to react with 4 moles of NH3. And number 8, um, if there is 200 liters of oxygen, how many moles of water can be produced? So first of all, I need to put in the directions. You got to balance this. I started you off with a 4, but you're going to have to figure out the other ones. All right, so first you're going to have to balance. I'll put that in the directions. You know what? I'll do that right now. This is how I would do that. All right, scheduled to be posted today at 9:30. Okay, so very similar worksheet number 1. Make sure you balance the equation first. Balance the equation at the top of the page, or you will not be able to complete the worksheet. Okay. And all right, so oops. All right, so we'll schedule that. All right, so anyways, let's go back to this now. All right, so I'm going to show you here 1 mole is equal to 22.4 liters. So it's probably take me 5 more minutes. So I'm going to go to the whiteboard here and show you how to do a calculation with that. Basically, once you get a balanced equation, if they give you liters, then you have to convert the liters into moles or the other way around. So you know what? Let me just show you. So I'll use a simple example here. Where's my thing? Okay, so let's go with, we'll just do the formation of water really quick here. What am I using? You know what, let's use Galaxy here. Isn't that'll be fun today. Use Galaxy, there we go. All right, so 2H, you know what, it's fun, but it's probably hard for you to read. So I'm gonna erase that. I feel like I need better contrast here. We'll stick with the green. All right, here we go. 2H2 plus O2 yields 2H2O. All right, so if the question says something like this, how many moles of H2O will be produced if, I don't know, 100 liters of O2 react? So at STP, standard temperature and pressure, and assuming these are all gases, gas, same thing on the worksheet due today, all gases. At STP, 1 mole of any gas occupies 22.4 liters of space. Also, 6.022 times 10 to the 23rd molecules or atoms. Remember the mole box I showed you a long time ago. In that box, we imagine there's this many liters that could be inside there. That's how many liters of gas will fit in that box. So this is a constant. At any gas, at STP, any gas, whether it's hydrogen, oxygen, water vapor, doesn't matter. You could vaporize mercury. All right, now this is really ignoring forces of attraction, but whatever. So that's more of an AP thing. So this is a standard. So if I give you 100 liters of oxygen, before you do the 1-to-2 ratio and figure out how many moles you're going to make, you have to first convert this to moles of oxygen, and that's what this is all about. So I'm just going to kind of rewrite this the way we've been doing proportions. If 1 mole is 22.4 liters, then how many moles are 100 liters, right? So if we have 100 liters of oxygen, how many moles of oxygen is that? So we cross multiply, and it's going to be 100 equals 22.4x divided by 22.4 divided by 22.4, and we're going to get 100 divided by 22.4, and x is equal, I'll keep 3 sig figs, 4.46 moles of O2. So yeah, these problems are more involved because you have to do all this first. Now, instead of reading 100 liters, what I'm going to say is how many moles of water, right, water, will be produced if 4.46 moles, right, that's a point, of O2 react. So I use this conversion, this standard, this constant, do a proportion, convert liters to moles. That's what I did here. Now I can do my regular stoichiometry problem. So I'm going to erase this. So now I can do my regular 1 to 2. 1 to 2 is equal to, so here's my O2. Here's my H2O. Sorry, that's messy. 1 to 2 is equal to 4.46 moles of O2 to X H2O. Now I can answer the question. So how many moles of water if 4.46 moles of O2, right? So we know if 1 mole reacts, 2 will be produced. So if 1 reacts, 2 is produced. How many moles will we get if 4.46? So we cross multiply. X equals 4.46 times 2. 4.46 times 2. I get 8.92 moles of H2O. So there's that problem. Okay? Now I'm going to clear it. And I'll clear it. And I'll use the exact same equation though. So let's say we have 2H2 plus O2 yields 2H2O. This time the question is going to say, all right, how many liters of water will be produced if, I'll use easier numbers here, 3 moles of O2 react, right? So now I'm giving you moles of O2 and I want to know liters of water. So now it's the same exact thing I just did, but in reverse, meaning now I'm going to do my proportion first. 1 to 2 is equal to 3 to X. All right, I'm going to speed this up. I'm not going to label everything. 1 oxygen, 2 moles of water. If I change the 1 to a 3, how many moles of water? That's going to be 6 moles of H2O. That's not the answer though. Now I use my 1 mole, I'll put it over here. 1 mole is equal to 22.4 liters. That's a constant. So now I'm going to use this number and this as a new proportion. So I'll do it right here. If 1 mole is 22.4 liters, then 6 moles is X. 6 times 22.4 is the answer to this question. 22.4 times 6, I get 134.4 liters of water. So I know I went quick through that one, but again, I figure because these are videos, you can pause it, look at it, try and follow, make sense. All right. So I'm going to kill this here, upload this, and then I will see you guys tomorrow morning and go over this, intro the next worksheet that's due, and then we'll start something new too. We'll do some more chem and math, or math and chem is what I call it. So we have more stuff to do. All right. Have a good day, guys.